My guess is that you're trying to put it in a way that it won't accept. Wait. What are you trying to type in?
I just have to type something.
What are you trying to put? But I want an equation, right? That's why I wasn't letting you, because you're trying to put a comma in there. Okay. You need to use mathematical operations. All right, so I know the timer's not quite up, but I do want to start talking, and I'll collect it in a second. Ethan, what strategy did you use? I'm not saying you got it right or wrong because I haven't looked yet, but what strategy did you use to try to figure out this problem? Made a table. Remember, and don't forget, guys, like, you can always create another mathematical representation to help you focus your attention, because which representation is the easiest to identify that rate of change? A table, right? So, with that in mind, Tyson, can you give me one point that is on that graph? 1,4. Do we agree? The point 1,4 is on that graph? Hey, Jacoby, can I get our headphones out, please? Jacoby. Not Jacoby, Z. Jacoby's way over here. Z, headphones out, thank you. 1,4, yes? That's a point? Okay. Any other points? 0,6. Why would that be an important one? That's our y-intercept, right? We always want that input of 0, because that's going to give me my y-intercept. Good morning, Traylon. It's good to have you here. You can smile. Or not. Remember, the choice is yours. Anyways, any other points that we can put up there?
-9.
What is it?
-1.
-1, you say 9?
Yeah.
Okay. So, we have those clear points. Remember, you need to look for the intersection of the grid lines to be able to identify those key points. Did she get it, Jalen? Okay. So there we go. All right, at this point I'm going to pause. And let's look at the answers to our bell ringer. Okay. I got 6 times 2 divided by 1 raised to the x. I do want to point out, okay, so some of us, okay, let's talk about a couple of things. I'm seeing some answers like this. What should jump out at us about this equation in respect to the function we're looking at? Guys, we got to notice that right away. What told us that this was an exponential function? Not just that curve. What type of curve? That's an exponential curve, right? The exponential curve immediately tells me that y is equal to a times b raised to the x. We got to know that. Which is why someone I saw put just 6 times b to the x, meaning they couldn't identify that rate of change yet. Totally fine, right? Somebody did say here, though, I saw this. Can anyone explain to me why that would not be what we want to write here?
Because they put the y-intercept where the other one is.
Yeah. Do we remember what the name of that is called? It is the rate of change, but it's called a constant. It is a constant multiplicative rate of change called a constant factor. Remember, we multiply with factors. Notice that exponent of x tells me to repeatedly multiply. Am I repeatedly multiplying by 6 here? That's a heck to the no, right? So we want to notice that. All right, so we do have a 6 times, we are missing that b right now. Traylon, do you remember how we can find that rate of change easily in a table if we have an exponential function? No? Okay, I'm going to come back to you in a second. Preston, do you remember how to find that rate of change in a table if it's exponential? Oh, guys, we got to know this. David?
Will you divide what is it called like 11?
Okay, so like if I take the 6, what would I divide it by?
4 or at 9?
Ooh, which one is it? Is it 9 or is it 4? It's always what is previous. Okay? Remember, we actually talked about this yesterday or 2 days ago. The idea is that if I take 9 and I multiply it by my factor, then I get 6. Right? If I take 9, I multiply it by my factor, I get 6. So to get that factor, that's 6 divided by 9, or 2/3. So Trayana, what can I do to get my factor easily if it's an exponential function? Not sure, even though we just talked about it? Okay, so we take, and I want to add a little bit of clarity, just make sure we're all there. Would this be my input or my output? This 6 here. Is that an input or an output? Input? That's 6. 6 is the y, it is just an output. So I'm taking my output and I'm dividing it by the previous output. The only reason I say that, Traylon, is we want to be careful. We need to pay attention to the order, because I could make my table like this, right? But if we're thinking about a graph, thinking left to right, what was actually previous to the 6? It's still my 9. So we always want to divide by that previous value. We don't want to just assume it's always above. I usually do make the tables like this, going from -1, 0 to 1, right, from left to right on the x. But we always want to divide by the previous value, because the idea is that I took 9, I multiplied by the factor to get 6. What is that? What questions do we have about that constant factor then? Y'all, it's a good day to learn. Y'all look dead, tired. What's going on? It's Friday. We tired. Does that need to make y'all get up, do some jumping jacks or something? No? Some of us? Okay, let's do this. Stand up, take 30 seconds, walk around the room, get your blood flowing, come back. When you sit down, I'm serious. Everybody get up, 30 seconds, walk around the room, get your blood flowing. Jayla, up, Z, up, Jamarcus, Phoebe, come on, stand up. We all are standing up, we're all doing it together. I'm going to walk around with you. Come on, Tyson. Come on, Shania. Come on, Ethan. Come on. Come on. Come on. Come on. I understand, get up with me. Let's walk around, talk about it. David. Come on, Hayden, come on. Hayden, I didn't ask. Tevin. Come on. Yes, walk 30 seconds, that's all I'm asking you. It ain't hard, walk around. Come on, Traylon. Come on, Sanaya. 30 seconds. 30 seconds, Jacoby. Come on, Desiree. Eliza, we ain't too cool for school. Stand up, 30 seconds, walk around, move it. Tyson, come on.
Or they do like that. Oh, it's like.
Alright, 5, 4, 3, 2, and 1. And let's get back to our seats. Alright. So, last little detail here. Right, we notice the y-intercept with my constant factor that goes right here. 2/3. Some of us are getting better at this. Hey guys, we've got to learn how to write this equation. Even if you don't love it, we've done this because I looked at the YouTube videos. We've been doing this for 2 weeks now. For as bell ringers alone, we got to know how to write the equation of linear and exponential functions. Even if you are like, but Mr. Kinney, I'm never going to look at an exponential function ever again. 1, you will see it on the ACT that you are taking later this month. 2, and more importantly, it's about learning how to think. It is about learning how to think. It's about saying, okay, what type of function is this? It's about saying, okay, I want to make a claim. The claim being, what is the equation I'm writing? That's my claim. What's the evidence to get there? We are way too used to, in this society, just jumping to conclusions, and either we know the answer or we don't. When that's not how life works at all, we have to build evidence up to get to that final conclusion. Okay, I want an equation. Okay, well, what type of function is it? Well, I see the curve is exponential. Okay, cool, it's exponential. I got my y-intercept. I know the equation. I got to find that rate of change. Well, let's change our perspective. I don't know the rate of change based off the graph. Let's look at it a different way. Let's look at a table to make sense out of it. There's a lot of life lessons here if we learn how to pay attention to patterns and relationships and learn how to learn and learn how to think. It is not just about math, it's about learning how to think. All right, all that being said, let's get to today's lesson. What is the point of an education? Why are we here?
To get a piece of paper?
Yeah, no, that ain't true. This is just get a piece of paper. This is the biggest waste of your time. Why are we here?
To learn, to prepare us for opportunities that are in life.
Okay, to prepare us for opportunities that are in life. What does that mean? Does everybody need an education 100% to get a job? A lot of people can make way more money than I can without a high school degree. So why are we here? My mom makes me come here.
Because parents will go to jail if you don't show up.
Because parents will go to jail if we don't show up. How about this as well? And this is something that you have to take upon yourself. There is beauty in the world around us that we cannot appreciate without an education. How about the people who have are kept in poverty, who struggle the most, are the ones who are least educated? How about if we don't learn how to think, then life gets harder. Your education matters, and I will say this, especially the Algebra 2 stuff that we're studying, the pure content side of things, it's not going to be the most applicable thing for you every day of your life unless you go into engineering. And at least from the conversations I've heard, most of us don't plan on going into engineering. However, there's still beauty in these patterns and relationships. We're learning how to look at a pattern or relationship and ask questions. Ask what connects these things. Your education matters because, yeah, it's going to help in a lot of cases us get opportunities that we can never have. That piece of paper, I will say, it opens doors. There's a lot of people I know who have college degrees who do nothing with what their degree was in, but that college degree did open doors for them. Not saying you have to do that. My brother, he didn't go to college. He actually went to welding school and now works at a gun store. It has nothing to do with welding. But the degree does open doors. It opens opportunities to be able to change your life. And more importantly, there's beauty in the world that otherwise you will never see if you don't learn how to think and learn how to ask questions. Please engage. There's beauty out there. If you come in with the mentality of my parents make me come here, my parents are going to go to jail if I don't come to school, then it's going to seem like a prison when it doesn't have to. Today's a great day to learn something new. Let's approach it with that mindset. All right. Well, it helps when I actually plug this in. So today is a good day to learn something. We're going to go back to lesson 4, true to form. It's out of the textbook. And then at least my goal is 15 to 20 minutes of Mathia. However, we do have to get to a certain point within today's lesson to get that amount of time. Right here, true to form.
What page is it?
True, that's a great question. It is page 45 or so, 47. 51. Wow, I was way off. M1-51. Right? This is the very first page. We're about to get right past this though. Do not forget, it is hard to learn what you're supposed to learn if you don't know what you're supposed to learn, which means we need to pay attention to the objectives. Can I get someone to read the objectives out for us? Go for it, Lily Kate.
I can identify the features of the parabola based on the form of a quadratic equation.
Is that a new objective? Where did we start doing this? In the last lesson, that Desmos activity. Remember, if you were not here at all during that time, I have the tutoring hours up here when I will be here after school or before school so that you can get help. I have the videos on YouTube. I actually have everything time-stamped, looking at what we did at different times so that you can use that resource as well. You can focus just on the whole class discussions, things like that. But we're trying to identify the features of a parabola based on the form of a quadratic equation. What are the 5 features of the parabola of the graph that we're trying to look at? There's 5 features. Vertex, I need one more. Concavity. Line of symmetry. Do I only have 2 students in here right now? Sanaya, do you know any others? The features of a parabola that we're trying to look at in those equations. We've got vertex, concavity, line of symmetry.
Okay, I'll be right
That's that concavity. The last two are the features we're going to look at in every relation that we ever study. X-intercept and the y-intercept. What are you saying, x-axis, Sinai? A lot of times people mistakenly say the x-axis or y-axis. Remember, we only want where the relation intersects the x-axis. So we're looking at the x-intercept, right? The x-intercept is where the relation intercepts the x-axis. And so we filled this out yesterday. Remember, we have 3 different forms. Guys, you have to know these forms. This is not the fun part, right? Jamarcus is like, Mr. Kenny, I'm already over all these stupid equations that I'll never use again, and I get it. However, to learn how to think and make claims and write equations and develop evidence for a claim, we have to know the equations and their names right away. By the way, it was on page 54, okay? M1-54, we already jumped there. We can do that. Yeah, M1-54. Standard form, right? Standard form is this top one, ax squared plus bx plus c. We have to know that form so we can identify a, b, and c. What were the characteristics, the features that we could easily see in standard form? The A controlled that concavity. What other feature could we easily see? The y-intercept was 0, c. Right? Ax squared plus bx plus c. When I look at factored form, we should already have this in our notes. What features can we see in factored form? X-intercepts. What in this factored form controlled those x-intercepts? R1 and R2. Do not forget the small detail that a lot of people skip over is I always need the opposite of R1 or of the sign here. Because it's x minus r1 and x minus r2, I need the opposite. What else can we see in that factored form besides x-intercepts? A, well, now be careful. A is a number, but that's not the feature. What does A control? Concavity, right? A controls that concavity. And the vertex form? Vertex, right? Mathematicians ain't original. If it's vertex form, it's because we're going to see that vertex. What else? Line of symmetry. And finally, concavity, right? So we want to keep those things in mind. So we should already have that in our notes. But here's where we're picking up. Remember, this is the lesson that I modified with some teachers around the county to give y'all, or this part of the lesson, to help give you a better idea of what's happening. So Christine and Kate were asked to determine the vertex of a quadratic equation given in different forms. Now, if it was vertex form, it's easy to identify the vertex, isn't it? Do they have vertex form? They do not. There are times in mathematics, and this is the thing, guys, it's not fun to have to learn these equations, but if we're going to study the rest of the mathematics, the beautiful part of it, we have to know these equations. There's going to be times when you need to be able to find the vertex. And so here's, regardless of what the form is, so here's Christine. The quadratic function is in standard form, so I know the axis of symmetry is x equals negative b divided by 2a. So, I'm just making up a graph, but she's talking about this line of symmetry, right? That line of symmetry always has to go through the what? What does that line of symmetry have to go through? The vertex, doesn't it? And so what she is noting, and this is the thing that like I just have to tell you, there's no way for me to explain why until you take a calculus class, but she is telling you that x is equal to negative b divided by 2a based on the a, b, and c from standard form. And so notice, what is b in standard form here? If I want negative b, b is, what is b? Look at that sheet of paper that you were given, guys. Not the. By the way, was anyone not here yesterday to get that sheet of paper, Hayden? What's the b value? 12? Negative 12? Anybody want to push back on b being 12 or negative 12? While I look for the sheet for Hayden. Hayden, I promise I have it. Made lots of copies. Here they are. Jalen? Oh yeah, you need it as well. 12 or negative 12? Which one is it? Is the b inside of that equation negative? Look at it, guys. Is that b inside of the equation negative? Nope. It's a positive 12, isn't it? So be careful about this. It's just right here, that says the opposite of b. b is 12. I just want the opposite of b, right? The negative b. Does that make sense, Ethan? So b is 12, but I get the opposite of b. Divided by 2a, what is a? 2. And so that's how she gets this format here. Now we already mentioned that that axis of symmetry has to go through the vertex, right? So didn't we always say, based on vertex form, that x was equal to h? Do you remember that? X is equal to h for that line of symmetry? So this is a detail that you need to note and highlight. This negative b divided by 2a, that's from standard form. And that might be a better place for you to put this right here, but this is from standard form. But it gives us our h value for the x value of the vertex, right? That negative b divided by 2a, that is the same value as h. Negative b divided by 2a from that standard form gives us the h, the x value of the vertex. They are the same. So I will point this out. They are the same, but they look different. So we would consider them what? What is it? Equivalent, right? That negative b divided by 2a is giving me the x value of the vertex. It's just based on different forms. Okay? Now, what's another name for the x value? If we're talking about a point, it's also called the what? Something we substitute in to get something out. So the x is my variable. It is a variable, but it's something I substitute in. So it's called my input, isn't it? Look at Christine's logic from here. Now that I know the axis of symmetry, I can substitute that value into the function to determine the y-coordinate of the vertex, right? So she took her input and substituted it. She substituted it in to get the output. Notice how she used that function notation. Negative 3 was substituted in for x. Substituted h in. Notice I'm always going to use h for the x value of the vertex. So she substituted h in. If h is what's going in, this negative 8 that she's getting out is the what? The output. What's the output for the vertex? What symbol do we use? Didn't we use k? H comma k for my vertex. So these things are all connected. That's the beauty of mathematics. We ain't just studying something random. There are connections among all these ideas. We substitute h in, we get k out. And that's how we would do it off of standard form. So remember, standard form was all about concavity and y-intercept originally. But now we have the line of symmetry and we have the vertex by using the a and the b. When we look over, let me pause because that has a lot of information. What questions do you have? We good? Okay. Jalen, you look like you got a question going.
No, I can't see.
What do you need me to read or say out loud so you can hear it?
No. Well, yeah. Yeah,
So-
that one.
That one. So where it says x equals negative b divided by 2a, I said that's the same as x equals h, the x value of the vertex. Right? That negative b divided by 2a is how we calculate h from standard form. Is what I'm saying there.
What's the one that start with is?
That's SUBST, substitute h in.
Okay.
That's all we're doing. We're substituting h in, getting k out. And so from that, she got the vertex. Now, read through that paragraph for Kate and tell me what she did. So I'm going to give you 30 seconds to read through this first paragraph here for Kate and tell me what she's doing there. So we've got 30 seconds to read and to think. All right, Jamarcus, what was Kate doing here? Can he come back to you?
Yeah, because I ain't read.
Oh, come on, man. Can't help you if you ain't engaging in reading. Z, what was Kate doing? Were you reading? Yeah. Didn't pick up on any keywords in there that tells you what she was doing? She was calculating in a what? An average. What was she calculating the average of? Yeah, but what are -5 and -1? Those are the what based on the equation? Those are the x-intercepts. Now I do want to clarify because I don't like this language. I should have talked about this with the teacher who wrote this rendition of it. Remember, those are not x-intercepts. The x-intercepts would be -5, comma 0 and -1, comma 0. The -5 and -1, remember that's R1 and R2, and what did that R stand for? Those were our roots, right? She averaged the roots. Well, why did she average the roots? It's not a random thing. Here's my x-intercept, here's my x-intercept, and if I had drawn it perfectly, this vertex is where in respect to those roots? Right in the middle. Mathematically, how do we calculate the middle of two numbers? We just, well, average. You add them and divide by 2, right? You're averaging those numbers. That's it. We're not doing fancy things here. We're not doing crazy stuff. We're just averaging those roots because the vertex is in the middle. That's it. So pay attention to that. That's what she did. Notice, did she get the same H as what Christine did? Yeah? Now that I know the x-coordinate of the vertex, I can substitute that value into the function to determine the y-coordinate. Oh yeah, because the H is my input, I still need my output, so I'm going to substitute it in, get an output out. So she substituted, oh man, I forgot to update this. This should, this should say, is this updated on your sheet? I forgot to update it on mine.
No.
It says this on there?
Yeah.
This should say, because I updated it from what we did last semester, remember this is, the x value is -3. So what's taking the place of this x right here? -3, right? That's my input. Plus 5 times,
12. I mean, ooh, my bad.
remember, I'm just using this function right here. So it's what right here? -3 plus 1. It's just substituting in, guys. Don't make it more stressful than that. And then simplifying. What's -3 plus 5? 2. -3 plus 1? -2. 2 times 2 times -2. What does that equal to? Remember, we're multiplying, not adding, right? 2 times 2 is 4. 4 times -2 is -8. So did we get the same vertex there? Yeah. These are different strategies to find that x-intercept, or not x-intercept, different strategies to find that vertex and that axis of symmetry. Because I know that x is always equal to h. So what would the vertex, or the axis of symmetry, the line of symmetry be for this function that we have in factored form? X equals what? Jayla, what does H stand for? It's part of the vertex, yeah. Which part of the vertex is H? Remember, it's H comma K, so it is the X value, isn't it? So X equals what? X equals, what's the X value? You don't know what, okay, you know function notation is f of x, right? So this is my input, my x, and it equals my output, my y. So if f of negative 3 is equal to negative 8, what's my x value? What's taking the place of x? Here's x, right? What's in the place of that x? So what is my x? I wasn't trying to call you out, but if you didn't realize that, ask that question, please. I want to help you. I want you to grow and learn. But x is equal to negative 3. That's my h. That's my x value of the vertex. Preston, you engage? Looks like you're staring off to the side over there. Huh? Okay. So how are these methods similar? What are they both doing? They're what? How are they finding the y-coordinate of the vertex? They first are determining the axis of symmetry, the x value of that vertex, right? So how are these methods similar? Calculate. This would go on the, I would put this on the paper. It's more accurate on the paper. Okay. I actually need to update this because that's the wrong piece there. But calculate the, what is the letter we're using to represent that x value of the vertex? H, right? So calculate the h, right? X value of vertex. And what? Once we calculate that h, what are we doing? What do they both do with that h value? Do they substitute it in? Because it's literally an input, right? We're going to write down substitute it in, but like that's just the facts. Like, why do they do it? Oh yeah, logically, because that's an input.
Teachers, pardon this interruption. Just a reminder that progress reports are go out second block. So if you have not checked your box to get your progress reports and you have a class second block, please do so as soon as possible. Again, that's progress reports go out second block, and those are in your teacher's box. Thank you.
And I believe the way I set it up was both Christine and Kate started out with that factored form, didn't they?
What is that? I see.
The what?
I think I'm gonna say K.
Yes, that's K. Because remember, H is my input, K is my output. I got you. But notice how Christine and Kate, I had them both start with that factored form, right? But Christine distributed to get standard form because she knew that equation for the axis of symmetry. This is again one of those beautiful parts of mathematics, is that there's flexibility based on how you approach it, right? So how are they different? Christine distributed to use standard form. Sorry, I'm trying to move through this quickly so we can get to the more important part of this lesson. We all get to cut stuff out, glue stuff down, the fun stuff. So Christine distributed to use standard form, and x equals negative b divided by 2a. It's a very straightforward equation that you do need to know. And so she knew her equation. She said, oh, I'm going to use that to get the h, the x value of the vertex. So what must Kate do to use Christine's method? Kate would have to do what first? So this is Kate,
Find out the axis of symmetry.
but remember that's one of the first things they both did. What Kate wants to use Christine's method. What would Kate have to do with her equation to be able to use that negative b divided by 2a? She would have to distribute first, right? She would have to distribute to get what form? Huh? Standard form. So Kate would have to distribute. To get standard form to use x equals negative b, or the opposite of b divided by 2a. And remember, the whole goal is that that negative b divided by 2a is the same as which value from the vertex form? Say it again. Is negative b divided by 2a h and k? It's just which one? H. Remember, it's just my x value. So Christine distributed. Kate said, forget that. I know that the vertex is in the middle of the what? The x value is in the middle, or the vertex is in the middle of what? The x-intercepts. So she just averaged her, what did she average to get her h? Which part of the x-intercepts? Remember, there's a name for just that x value of the x-intercepts. The roots. Right? Average those roots to get an h. That's it. You can memorize the equation that, because there is an equation, r1 plus r2 divided by 2, but if you know how to average stuff, you don't have to memorize an equation at all. You can just average the roots, which is a fantastic thing to do. So we're going to use this information in the next part of this, which is the more interactive part. So we're moving to number 3 in the book. It is on page 56. Okay. I believe I have already set everybody up to be able to cut out each quadratic equation and graph. There are quite a few scissors in each of the boxes. So get the scissors out from the pink boxes. You're going to move towards the end of the lesson. You're going to move to page, really far back, 69 and 71. And you're going to cut out those equations and those graphs, right? So page 69 and 71. M1 dash 69 and M1 dash 71. Cut out equations and graphs. I'll give you more instructions after we get those cut out. If there's an extra pair of scissors somewhere, let me know so I can distribute those as needed. Please try to cut quickly and efficiently. I will collect the trash. Hold on. So one thing to help in this in the future, if you put your hand down here and lightly pull, so let me get that. So if you do this, or you just lightly pull like this, you pull this one. put this. That should pull a little bit more even. Oh, it is a pain in the butt. What do you do? Why is this not something? Sorry, Kevin, I know I need to get a couple more scissors, I'll try to do that. Huh? Yeah, no, no. Yes, sir. Hold on, I can't hear you. Were there only 2 pairs of scissors, y'all? Oh, I thought I had 3 in there. Oh, you have them. Well, David, start cutting. What's the issue? Oh, that'll be, yeah. Yes, you need the graphs and the equations on page 69 and then page 71. Oh, stop that. I was trying not to. There we go. Whew. Managed to barely say first. Now, once you get it started, this strategy where you do that usually works for you. Can you wait till you get that stuff cut out, or do you need it? Huh? Let's give Shania her the scissors so that she can work while you're gone. Put it good and tear your pages out so you can start cutting into this section. There we go. Just kidding, you crushed it. Alright, does anyone need scissors because they haven't had any yet? Tevin? When I order more scissors, I'm getting you a pair of left-handed scissors.
Okay, thanks. I didn't use left-handed.
Huh?
Yes, I did.
I was like, do you see that? It's painful to watch.
My mom got me a left-handed can opener.
Really?
And I ended up breaking it because it was a lot. But I think,
When Eliza comes back. Alright, I'm about to give instructions for the next part of this. So make sure you pay attention to the instructions. If you need to continue cutting in a second, you can. Alright, so pause for a second so you can get the instructions to make sure that you know what is being expected out of you as we get started with this. So can I give these instructions and then go? Alright, so we have a total of how many quadratic equations? 9 of them. How many quadratic, or how many parabolas? Also 9. Our job is to pair our equations with the parabolas. Okay? Our job is to pair the equations with the parabolas. You will notice that I have each group assigned to a different space around the room, because what I want you to do is do not glue yet. Now, when you do identify something that goes together, we are going to glue the equation onto the graph at the bottom. But what I want you to do before we glue, because I have students every single semester go, oh my gosh, now I have to tear this off and re-glue somewhere else. Don't do that. As a group, when you identify a pair that goes together, write it up here. And what we want to notice is some of them are in standard form, some are in factored form, and some are in vertex form. Okay? If there's 9 equations, how many of them do you think are in vertex form?
30.
Probably 3 of them. How many in standard form? 3. And how many in factored form? 3. So for every group, what I want you to do is I want you to write vertex form. I want you to identify factored form. And I want standard form. And then if you think equation F goes with graph G, show that. Right? And I don't know, what is equation F, actually? What form is equation F in? Look for equation F. What form is that equation F in? Find equation F. What form is it in? What are you thinking, Rakai? Standard form? Is it an ax squared plus bx plus c? I guess I should write it up here. It's x squared plus what? 12x plus minus 1? Does that follow the standard form format of ax squared plus bx plus c? Yes. So I wouldn't put equation F under vertex form. I would put equation F under standard form, and then draw an arrow to what graph it goes with. Please note, the equations are lowercase letters, the graphs are uppercase. This is how we're going to look around the room and check to make sure that everyone has them right before we move on. So, you can stay at your desk, sort them, try to pair them together, do not glue them yet. When you've identified a pair that go together, make sure that you sort it into the correct form. Does that make sense? Alright, you can go. We need to go ahead and start sorting. Remember, I want active collaboration. I want to hear talking. The person who talks the most learns the most and doesn't drop expo markers on the ground. Alright, let's get to work. Yes, sir.
I put it back.
Jeremy, need your equations out? I got you. But they can stay over there, write it, and they can tell you where to put things. If we had paired them along with Jacoby, I'm saying them, if they had paired them along with Jacoby, now that you talked with them, make sure they understand what's going on.
We never did that. We said,
I got you. Alright, let's get our stuff up there. We're about to start in just a minute.
What graph?
What do you mean put?
About 30 seconds before we get started.
Okay, we got.
Huh? Just in general?
Little b,
Wait, graph E? Where does that get started here? Alright, grab a seat where you are. Let's check where everyone is. So we didn't get all of our equations and graphs up, but a couple of the groups did. Let's check with where we are. So first off, vertex form. Did everyone have equations G, I, and D in vertex form? vertex GID, vertex GID, vertex GID. All right, so it sounds like we're all in agreement. Vertex form is GI and D. We good there? Do not forget the basics. Y equals A parentheses X minus H squared plus K. Right? That's our vertex form. If it follows that, we're good. Factored form, CA and E. CAE, CAE. All right, we're looking good on the equations. That's our factored form. Y equals A times X minus R1 times X minus R2. And standard form A X squared plus BX plus C. And that would mean our standard all is the same. So equation G mapping to graph H. Does anyone need to or want to push back on that? G going with H. I see one over there that disagrees. This says G to H, D to H. So is this group 1? Why did y'all map equation G to graph E? Equation G, I'm looking for it. Okay. Why did y'all map equation G to graph E? What were you seeing there? The K? Okay, so, I got you. So, well, so what do you think, so you thought you knew it was concave down for equation G? What did you think the vertex was? If I have, what is that? F of X equals a negative, parentheses X plus 4 squared minus 2. What do you think the vertex was there? A 4? That's the entire vertex? How do we identify our vertex, guys? H, comma, K. And don't forget to go back to the equation. Remember how it's X minus H squared plus K? So what is my H value again? Is it 4 or is it negative 4? Remember, I need the opposite for that H there. So negative 4, comma, negative 2. So look at equation or graph E. Does it have a vertex of negative 4, negative 2? Nope. So equation G went with graph H. Nobody else wants to push back? We comfy with that idea? So make sure you put equation G onto graph H. Say again. Hold on to gluing. We'll do that in a second. We're going to go through each equation and graph first. All right, so equation I see graph G across the board. So what did we see in equation E that put it with graph G? Again, vertex form. That negative in front tells us the parabola is concave down. And what is that vertex in equation I? Negative 2, 4? We all agree, negative 2, 4? Look at it again. It's not negative 2, 4.
Oh, what? Okay.
Look at equation I. The vertex is not negative 2, 4.
Oh, negative 2, negative 4.
It's negative 2, negative 4. Remember, we only take the opposite of the x minus component. Cam, can you let Haley in? All right. Oh my gosh, I'm so sorry, Jacoby. How did that happen? All right. So, equation D with graph D. Oh, we are all over the place on equation D. Did both of y'all say L? Is that an L or an I back there? I? Oh man, we are all over the place. What is the equation for D? X minus 1 squared? Alright, that's equation D. What do we know about this equation? That is, what? What's up? So concave up,
It's vertex.
it's vertex form. So what is the vertex if it's in vertex form? Start at the basics, what's the h value? No, I mean like looking at that equation, what is h? Is it 1? Or do we need negative 1? We need positive 1, right? It's x minus h. What's the k? Say it again. There's nothing written there. So it would have to be an understood plus 0. So the vertex is 1 comma 0. So what graph goes with equation D again then? It's not that, is it? Could it be,
It's off.
is it graph I?
It's off.
Everybody look, graph I, does that have a vertex of 1 comma 0? Okay, so we need to update this. Graph, or equation D goes with graph I, which means we're going to have to update this a little bit later. Okay. Questions, comments, concerns through that vertex form? Factored form. Equation C went with graph E. Does anybody want to push back on that? Did everyone have C with E? Alright. Questions, comments, concerns? Or we're moving on? And remember, if you have to update and fix something, then that's a good time to ask a question. I highly encourage questions. The more questions you ask, the more you learn. Alright, I have C with E as well. Equation A with graph F. So that's not what we have back here. We didn't quite get it there. So we need to look at equation E, or equation A. Equation A says f of x equals 2 times x plus 1 times x plus 5. Okay, so let's go to Trayana. Trayana, what form are we looking at here with this one again? Huh?
I can't even see it.
Okay, it's equation A. Do you just need me to write it bigger?
No.
Okay, which form is it? It's factored form, right? So Miracle, what features can we see in factored form?
The x-intercept,
The x-intercepts and
the concave.
concavity. Jalen, what would the x-intercepts here be for this equation?
For A,
Mm-hmm. Say a little bit louder.
or no, that's 5.
That's 5, yep.
Is it 5?
5. Now remember, an x-intercept needs to be a point, right? So you're thinking, what would the point be?
Oh, is it 0, 5?
Close. Remember, the x-intercept is, oh, you weren't here yesterday when we did all of this. I'm so sorry. The output, the y value is 0 for an x-intercept, okay? Does anybody want to add on to or push back on it being 5, 0? David?
Oh, no.
Are you just stretching? You think it's negative 5, 0? Why do you think it's negative 5, 0?
You do the opposite.
Do we need the opposite with that factored form, x minus r1 times x minus r2? Well, if we have x minus, to get a plus, I need to subtract a negative, don't I?
Yeah.
Uh-huh. Yep. So we needed a negative 5, 0 and a negative 1, 0, meaning I believe that pairs equation A with graph B. It sounds like we might need to flip those. So B and F here. What? Equation A went with B. Equation E then goes, is it F? Did I switch that right? Because notice x minus 1 times x minus 5, that would give me a 1 comma 0 and a 5 comma 0. Okay, yeah, y'all didn't even get those up there yet. Alright, so we are on to standard form. What would equation F have to go with now? Graph D? Yeah? And it's hard to see, but if you look closely, that y-intercept could be a 0, -1. So those are correct. Which of these do we need to wrap up talking about to help you have a better understanding of these concepts? So that means we understand this. There's no questions. All right. You can start gluing your equations to your graphs. And I apologize, I had planned to get to Mathia. Since we did not get to any Mathia today, your Mathia assignment is due on Sunday. I would knock it out during enrichment. I know at least, hey, Jamarcus, it was due tonight. So I'm giving you an extra 2 nights to work on it.
Is it Sunday?
I'm saying it's due Sunday. So just glue the equations to the graphs first. Just glue the equations to the graphs first. Yes, Haley?
Everything on that board right there, right?
Huh?
Yes.
Turn what in? That's in the book. So the end of that lesson. Nope, not the back of the book, just the end of that lesson. It's like page 57 or something like that. Maybe a little bit later. So put your equations with your graphs.
Okay.
I think. No, it's not. They on it's another page. Please, let's not.
Chasing niggas out of parties and shit, that's a game.
That's not happening.
Why do you feel like you have to be skied up before you
Can you tell why he's not there? Oh, really?
Okay. I need to buy some more, but just share with each other. Now, you don't have to make the thickest lines in the world.
I think she just grew
Okay?
Or you like, I don't like this.
Okay.
Or you can try to, I know I did on my head, but we type it. You can try to break it,
Once you get your equations glued to your graphs, hey guys, stop and listen. Or stop talking and listen. Once you get your equations glued to your graphs, go to page M1-73. We don't have time to glue right now, but put your graphs and equations into your book at page M1-73. Just make sure they do not fall out. If you want a paper clip from me, let me know.
You said what it might be, because then I saw
Paper clip?
I saw none that hating you guys.
What happened to calling your date?
Anybody here want a paper clip?
No.
Paper clips? Are we good?
Go look at Granny's page. The class is over with.
They don't have anything to do with parabola, bro.
David, that's nasty.
Go to Granny's page. On the back of you. Yes, it is.
Little C to big L.
Notice F goes with E, equation E. Hey guys, pause and listen really quickly, because we did not get a chance to go to Mathia, but there's a couple of things that you need to be aware of when it comes to the Mathia assignment. Look up here. I already saw some students getting frustrated with trying to create these expressions. First off, you can always use the hints option because the point of this is to learn. Second off, could you make a table here?
Yeah.
Yes. With all of these, we have a design and then we have the number of squares. And so design 1 has 2 squares, design 2 has 3, design 3 has 4, design 4 has 5. Is there a pattern there to help us write an equation? Yes. Hey guys, Phoebe, Jalen, I'm trying to teach here. Please pay attention to those patterns to help you write those equations on this page. Beyond that, comparing families of functions, this is all about identifying the equation that goes with the different types of functions. Read the information there to help you. I should have done this before the understanding check, and I'm realizing that now, but I will fix that for the future. Please pay attention to this though. Okay, this is the last workspace that you need to do. I recommend beginning the step-by-step example so they can help you, but what I want you to see is this.
No.
Right here, number of y-intercepts, there's 1. You select the point. That's my y-intercept. Number of x-intercepts, there's 1. Select the point. It's right there, crap. Have a good rest of your day. Please use the hints because this is doable. Use it to learn. Thank you, Naisha. That's the last one you have to do. You only have to do units 1 and 2 on Mathia. Because if you're struggling to master the skill, it's going to keep making you practice.
Hey, I know you. I know you.
Well, are you having to use hints to get it right? So you have to get it right enough times to stay yes. Because if you can't consistently get it right, do you fully understand it? No. And that's what they're trying to make sure you fully understand it. Does that make sense? So I know it's a pain in the butt, but it's going to make sure you really understand. Huh? Such an artist. This was yesterday.
Oh my God. Dr. McKinney.
Bye, Cincinnati. Have a good one. Good morning, Caleb. Yeah, you are. Good morning, Kason.